finally you're gonna find something that they did it wrong, not the same as others out. And then we fix it and then we control it again. So this is just the control chart concept. So this is the example of the quantitative diagram, right? It's used in the case of the problem is about uncertified of the airline customer. Then this is quite a brainstorming, right? Maybe from the broken luggage, maybe it's from the inadequate magazine, maybe it's from the overbooking policy, by things that this can be that you brainstorming. This is the example of the parallel chart, right? Just like you have the problem of the hotel, right? And you list the cause of the problem. Maybe come from the room service, come from the checking in, come from the pool hour, come from the minibar, and so on, right? And based on your information, room service is about 54 frequency, right? Checking in 12, room pool hour 3, this one 3, this one 2, and then you calculate the percent, cumulative percent, right? 54, right? The form overall is taken account for around 72%. And then you combine 54 with the 12, you have 66, right? 12 is around 16. So when you combine both of these together, you allow 88%. So in this case, if you want to reduce the problem of this hotel, maybe you can handle first two costs here, room service and checking in, because it takes account for around 88% of the whole problem, right? So it is just like, this is the scale for the cumulative percentage. This is the scale for the frequency, right? This is a list of the cost, right? And then we got in the graph and take care of that one. The flow chart is nothing much, so it's like a process of packing and shipping. It's not that complex, so just example to show you. Okay, and sometimes the process we can have in several ways. You can even though identify about who have that responsibility for that process or that activity, and also you can edit specific about the time to do that activity. This is the SPC that I just mentioned, right? So we're using about the statistics to handle and test about the process that you interest that is in or out of control, right? So we measure the process, we look at the plotting. The variation that is not come from the natural, we call assignable variation or assignable cost. We try to eliminate that assignable cost. Assignable cost or assignable variation is come from mistake from the workforce, the take from the procedure, the wrong or not calibrate or setting up the machine, or some from the machine breakdown. And this is quite the example of plotting. We're gonna have this one for next week, right? It's like the calculation part, right? And then we have the should be last case study. Okay, last one for inspection before we have you to have that presentation. So the inspection, as I mentioned, that is involved about the way that you try to examine the item or detect, right, the item that it is good or bad, or this is good or it have a defect, right? So it doesn't provide, right, or adding the value to the product. So it's not the correct way to handle or enhance about the quality to the products. It is expensive because the more you inspection, the more cost it's gonna pay for the people, right? And don't forget that people can have the mistake, right? Based on their fatigue, based on their interesting, right? Just like that, it's like a joke, right? So I don't know, this is your second term, right? This is your second term when you study, right? I don't know that how about your performance, about your bachelor study, but normally it's just joke, okay? I'm always talking about my master student that, okay, sometimes they try to reborn when they study the master degree. So when I don't know what happened to my bachelor degree, but right now I'm gonna starting the new performance, I'm gonna do my best for my MBA. So this is the first day. I'm gonna pay attention. I'm gonna go the good way. I'm gonna good grade. I'm gonna do everything best. This is the first semester that student, especially for the MBA student, thinks because they're carrying that okay, the past for one way is not good, but now is time to reborn. It's time to, time to change everything again. But if I ask them at the last semester or the semester before the last one, the answer that I'm going to get is about we study MBA, we are not paying attention for the grade. We're looking for about the connection, about the networking. So who care about the grade? We just pass this. We just want the connection. We want something like that. So let's see about you guys when you have the last semester. So we study at first, you have a lot of energy, right? You have a lot of hope, right? What you're gonna have for the master degree. But the last semester maybe it's on another way. So it's just joke, just joke. Just this one, right? I mean, inspection as well. The inspector at first they try to do best, right? But they have a lot of energy. Just like the police, right? To perform like their best when we have the new regulation about the traffic. They do a lot of things because catch arrest that one, do other things. Right? Let's say that you think about the motorcycle that don't have like a helmet. That at first they do a lot of things. But when the time passes or the time goes on, what happens? But there's consistency is reduced, right? Just like inspection. At first they do best. And after that, maybe the consistency is reducing. They have their fatigues. They cannot perform well as the beginning. Something. So that's why you can have another problem. So the issue is that we know that inspection is not the good way to add the value to the product, but it still need to have it, but not that much. The problem is when to inspect and where to inspect. This is the list that I read it and I think it's almost every point of the process. Right? This is just like the popular one that when and where to inspect. So at the supplier plan, right? When you receive the good from the supplier before we do the very costly process, in the step-by-step of the production process, when you finish, when you doing before you deliver to your facility or at the point of the customer contact. So inspection, right? Sorry here. Problem. Inspection has many problems, right? As mentioned, worker fatigue, measurement error, right? Because you have inconsistency, you have the process variabilities, so it not add the quality to the product. So what would be another way to handle, right? Robot design, right? You design a product that can use or stay in every variation condition, or empower the employee to make the decision to handle the problem, but find the better solution. But anyway, inspection also is still important because we need to have it as well. But at some point, in the Japanese world, right, we do have the point that very critical that we need to investigate because that point is about the Hokkaido gate, right? Hokkaido gate is about the way or the concept that you try to investigate or inspect the process to make sure that there is no mistake happen at that point, right? So the Hokkaido gate is quite important when you do like the production. We still need to have it, but it doesn't mean that every point you need to have inspection. But some critical point, sometimes you need to have like the Hokkaido gate, right? Hokkaido gate is like the process that you try to prevent the mistake that's gonna happen. So in the production process, let's say that Hokkaido gate maybe let's think about the way that you let's say that assembly about the notebook or the computers, right? How can we know that we using all the bolt fit into the notebook, not forget just one of them? So very easy for Kaiyugen is that you using all the bowl stain that throw it in the tray right out in front of you before you make the assembly things. And when we assembly before you send to the another station, just look at the tray. You still have the bowl left or not, something like that. So this kind of very simple for Kaiyugen. Or even though your car that you drive every day, they also have the Kaiyugen. How can we know that we forget to turn off about the headlight of the car? When you forget to turn it off and then you stop the engine, they're gonna have the sound or something. That's called Kaiyugen. How can we know that in the McDonald's restaurant that everyone who buy the Big Mac gonna have the same quantity of the French fry? So they use the case of the French fry. If you use this case and you try to change it from the from the oven or whatever, using the same case, we imply that we have the same quantity. So that's kind of for Kaiyugen. Okay. So this is a list, just nothing much, just a few details that let's say that you have the law of faith, what kind of you need to inspect about the accuracy of the building, how about the receptionist when you have the phone ring, right? So or even though about the hotel reception desk, the doorman, the room or minibar, this kind of thing that we can inspect or have the standard to check with the hospital, right, lab, right, buildings, something like that. Okay, or restaurant, busboy, waiter, waitress, right? So nothing much. So just example. Or the display area of the department store. So we can see that actually inspection is still important, but it's not a good way to add the value to the quality to the product. But we still need to have it some point. Right? And how about the TQM service? Right? We can apply we can apply TQM service as well, right? Just using the same framework, right? We all know that the service is quite difficult than making the production of the good because the service has the interaction a lot with the customer, and we play with expectation of the customer, intangible, right? But we still can apply, right? So let's think about the service qualities, right? We have like this is quite a list of the service quality thing that we can do. Right. First is about tangible component is quite important. Right. What is this? It's just like that. Okay. Even though that let's say we have the restaurant, right? We have the new restaurant, right? It's located between the way that you going from your home to your office. Comparing these two restaurants, one restaurant is when you drive the car past it, you look at that restaurant. That restaurant is look not that clean. It's not that have much more enough of the light, right? The waiter or waitress is have wearing that's not the same uniform, and the parking space is not that much, right? So what do you feel? Maybe we not even think that going to try that restaurant. But comparing to another restaurant, you don't know that is this good restaurant or not. You don't know what the taste of this food. But when you drive your car past every day from your home and your office, you look at the decoration is quite beautiful. They have plenty area of the parking space, enough light. The waitress and waiter have the same uniform. Looking inside, they have like the appropriate arrange of the seating, and have that everything look good. So every day you pass it. What you gonna do? Stop one day, you may think that we're gonna try just one day, right? So my point is that service quality is starting with the tangible, even though the service is involved but intangible, but just let the tangible thing is quite important. Cleanliness. Just like the cleanliness, about the decoration, all everything can make the customer feel that hope that you're gonna have the very good service. The second thing is about keep the process also important. Think about the way of the process. Right? Think about the concept of the moment of truth. It means that the critical moment or the contact point between the service provider and the customer, which contact point that the customer can make a decision to happy or unhappy. You need to make that contact point being best, right, for the customer. We call the moment of truth, right? Try to handle the critical moment that customer gonna feel good or bad, right? And then the third and the fourth one is quite simple, that we are doing with doing service with the customer, so we play with the expectation of the customer. So we adjusted based on the expectation of the customer. So we cannot please all the customer. Right? So please all, please not. So it's gonna be some point that still have some customer that is unhappy with your service. So just forget it. The exception will occur always. Right? And this is the things that we're going to show you about. This is like the specification of the driver of UPS, the company that deliver the products, right? They have their standard. The driver is going to be the one car for one driver. One driver, that driver is going to have like this, the standard, right? Right? The shirt inside T-shirt is going to be white or brown. The policeable shoes, and when you're carrying about the box or the parcel, do not run, something like that. But actually, I found the real one is not that way. Right? It's a big guy, right? So, and then you can knock your door is really hard, right? Because make sure that you will stay inside, right? So it's a big one, right? But actually, so it's just they have like a standard. So just like that, if you have something like a standard, so what can you feel if you were the customer? So think that, okay, this have their more standard, you're probably more, good providers of the service, something like that. Lastly, right, this is a list of determinants of the service quality. We can think in the term of, access, right? It's quite important how easy that customer can access to your service. Right, communication, right? So, or even though the credibilities, right? Credibilities is quite care about the qualities, things. Understand, knowing of the customer, your security things. So that. So this is the example. For example, convenience. So this is close to the customer. Reliabilities. They can be solved as always for the problem. Responsiveness, where the customer service personnel willing or able to answer the question. How about the waiting time? Is long or not? Assurance, do they have like the warranties or knowledgeable about the repair or something like that? So it's quite a general things about the service, but it's look easy, but it's not that easy in the real world. So because we depending on the people and the expectation of the customer, right? And it's intangible, right? So a lot of companies have good product but bad service. But we have no doubt that nowadays the service after sales service is quite very, very important, right? And sometimes it's just a joke in Thailand that sometimes for some business we have no choice. Just like that, you are not happy with DTAC, you go to True. And then you're not happy with True, you go to AIS. And when you are unhappy with AIS, you back to DTAC again. So sometimes we don't have choice but about the business. But if you can have the good service, maybe you have the better chance to retain your customers, something like that. Okay. So it's just like the rough information about the quality management. Okay. So next week we're gonna study more about the quality control. Or the way that we construct the control chart is calculation, right? And we're going to talk about the process capability, the way that we analyze the process that perform the output within the specification or not, something like that. Okay, so next, gonna let you to do the presentation, right, about the design of the product layout of the Toshiba notebook case.
Great. Good as this one? I am very warm. Right? Yeah, but I am very warm. はい。ねえ、ねえねえねえね
Hot chocolate. This is hot chocolate.
え。はい。
Very inside.
Yeah. Looking good. This group deserves a good buy.
Free and free. Right. It's like real people has exception in context. The original is verb and verb plus s.
Verb plus S.
She has.
Is this the
I
right
have.
level of volume for you? Not too loud? Okay, good. So today we're going to present the case about Toshiba's notebook new models and how they design the assembly line. So first, I'll go through the cases for you before we go into the questions. Okay, so basically the main character here, so everyone is his name Toshihiro Nakamura, which he is a manager in the manufacturer assembly. I think his position is very long, so I'll just go on to refer to him as a manager. So basically, he works for Toshiba, and Toshiba wants to launch a new sub-notebook model. And the engineer who actually designed the notebook decided that there should be a new assembly line that goes along with the new notebook. So that also goes with what the managers think. So the manager thinks that every time you launch a new product, a new model, you should design the assembly line to minimize the parts and also to reduce idle time. So that's why your job as the manufacturing manager is to review the process assembly line like a draft from the engineer. So the product will be launching in 10 days. At first, in the first week, the management and engineer expects the product to be 150 units per day. And within the following week, they expect that the maximum capacity will reach 250 units per day. So the engineer designed the assembly line that there will be 10 workers. They will be working from 8:15 to 5. In that 7.5 hours, it will include 1 hour lunch break and 15 minutes short break. So when calculated out, that will be 27,000 seconds a day. So this is what the initial design and engineer design looks like. So we have 10 workers. We have 10 workers working in a conveyor belt. So it's a long line, and then the total meters of the line is 14.4, and the line will be split by a white line into 1.2 meters per station. So each of the components will stay on the conveyor belt, and then it will move through the process from the first worker to the second. So one of the first stages, what they will do is that they will place all the parts in the conveyors, and then they will scan them, barcode them, and then the little guys, they will start to assembly them. So and there will be a tools. The tools will be hanging on the cable, and then whenever they want to use it, they can just drag down from the cable and then use it and let it back up. So that's the ease, help them to work faster. But there is a little bit explanation need here. So basically, in this stage, what they do is that they do a software, a test on the computer whether every parts work efficiently. So what they do is that they insert a kind of software that will test run all the computers. However, the software takes 4 minutes to load, so it takes more time than all other stations combined. So what they do is that one worker, they split it. They do three computers, 3 units at the same time. So the overall station will use 310 seconds, but per unit it will take only 103.33 seconds per unit. So apart from the 10 workers, there's also one supervisor. So the supervisor is a skilled person that actually helps those who fall behind, or if they need a break, like they want to go to the toilet or everything, that the supervisor will jump in. And but when they finish the last, they will go into what we call burn-in stage and then install the software and then packaging it. So usually the assembly line will carry about 8 to 12 workers depending on the skill and the availability of the workers.
Okay, next we're gonna talk about the questions. So from the assembly line, we're gonna see that the time used in each station. So since this station consume only 1/3 for each unit, so the next bottleneck is gonna be the second station, which costs 114 seconds. So we determine this is the cycle time. Okay, so the first question is, what is the daily capacity of the assembly line design by the engineer? So the assembly line, as we get from the case, we have the operation time per days and the cycle time that we get from the last slide, which is 140 seconds. So when we calculate and then we get the numbers 236 units per day, which is still does not quite reach the expectation that we made, which is 250 per day. Therefore, the second we're gonna calculate the efficiency that we get from the last questions. So we calculate the idle time. We're using the cycle time, the bottleneck cycle time 114 as the main one, and then we deduct it by the time we get from each station. So we get all the idle time, and then we calculate the total idle time, which is 88.67 seconds. And then we calculate the percent idle time using the idle time in the cycle, the number of stations, and the cycle time we use. So I calculate, we get the 7.78%. And we use divided by 1 to get the efficiency percent, which is 92.22%. So the third question, since we have to redesign the assembly line in order to get the target, which is 300 units per day, assuming no overtime. So our choice is, if we increase the expected capacity, then we have to reduce something else. So the one that we decide to reduce is the cycle time from 140 seconds to be something else. And after our calculation using the expected daily capacity, then we get the cycle time, which have to be 90 seconds from the first one. And I will hand over to.
Okay, as Neil already mentioned, if we want to increase daily capacity up to 300 units per day, we need the cycle time need to be 90 seconds or less. So what we do is that we will have to regroup the operation in each station and to make the time used to operate in each station less than 90 seconds. So this is what we do. So if we look at the first station, we will make it parallel. So we add more station we add more operation in the first station, and total time used will be 173, and we use 2 workers on this station. So on average, we will use only 86.5 seconds. And for station 2, 3, and 4, we just use less number of operations so that the time that used in each station will be less than 90 seconds. And for station 5, 6, 7, we do the same thing. We reduce the number of the operation in each station. The same for station 8 and 9. And for station 10, we do the parallel again, but this time only one worker, because this person can take care of the operation number 63 alone, and they can make 3 units together, only one person. And on the last station is station 11, we use 2 workers to process the work, and we will have average time use of 88 seconds. So, in summary, here's what the redesign looked like. We use 2 workers in station 1 and station 11 and make it parallel, so they can make like 2 units together. And on station 10 is the same as the current design, so use only 1 worker. And next, if we calculate the cycle time of the redesigned station, the idle time is only 48.67 seconds, and percent idle time will be 4.25, and the efficiency will increase to 95.75%. And if we compare this number to the current station, you will see that the redesigned station improved a lot. Let's compare other things too. So right now we have current station, we have 10 station, and we increase it to 11, but we use 13 workers instead of 10 workers. And the cycle time will reduce to 88 seconds, and maximum capacity will increase to 306 units per day.
So, okay, for the last question, what other issue might Toshihiro consider when bringing the new assembly line up to speed? So since from the case, we do not have very much information about the limitation of the factory, so we don't know whether we can, like, what is the space? Is there like limited space, or can we change the whole conveyor? So we assume that everything can be changed, including the number of the workers as well. So the points to consider would also be the worker behaviors issue, because this is a new assembly line, so it will take some time for them to actually get into sync with the process, the new process, and there will be some kind of learning curve to adapt themselves to a new assembly line as well. Okay. And so, as I mentioned before, we don't really have information about the budget. So we're assuming that all changes can be done. So we can hire new worker. We like additional 3 workers without worrying about the budget. And in terms of the conveyor, like I said before, we do not have the limitation. So we're assuming that the conveyor can be adjusted up to 13 workers. And as I was saying, the conveyors were split into 1.2 meters, so it can be split maybe in 1, or maybe purchase the new conveyor altogether to accompany 13 workers. And that's, by changing the conveyor, Toshihiro might need to consider about the factory space as well, whether it can accommodate the new conveyor or not. And so that's it from our group. If you have any questions, we're happy to take it.
Okay, good job, but please go back to the very first one. Yeah, the first. Yes, this one. Why you think the cycle time is 114? How about that's kind of parallel station? What did you do about that? I mean, for the current station number 9, right? Station number 9, we have the operation number 62, 63, and 64, right? And what do you think about that? You didn't mention about that much, but when you show the calculator, you said the second time will be 114. You just divided 3.
Yes, because they can produce 3 units in 310 seconds. So in average, they produce only 1.
And you think because it's parallel, so you just divide it by 3, and then you take out off for section number 9, 310 divided by 3, so you have 103.33 is less than 114. So then you think the 114 is going to be the cycle time. Am I right? Okay. And actually, when you do the question 1, question 2 is okay, right? The way that you do it, that actually is correct answer. But one thing that I want to clarify is that the station number 9, actually the operation number 63 is about the software loading, right? It's not have the operator. So actually, when you do that, you can eliminate that time. 208 second. Okay, so it's gonna have like actually station 9, you're gonna have the time around 1 and 2. So because it's not performed by the operator, right? It's tell that it's not performed by the operator, right? So you just cut it off 208, then you can have the station number 9 102, and just write the thing that you do. 102 is less than 114. So then you do this under this way. And another way is that going to your second question.
For goals? For me?
Yeah. So
Show me again.
the one that you have your efficiency around 92 is question 1 or question 2. Yeah, this one is correct, right? But you show a lot of detail about calculation is good thing. But one thing that you can do is very fast, real fast. It's just you collect all the time required and deduct 208. And you're using the formula of the efficiency or percentage of either time, and you're getting the same number. Okay. It's okay, just that's it. So the rest is okay. Actually, if you're using the concept that I tell you that the operator is not required for the software unload. When you do the third question, right, the one that you try to increase the efficiency, so you're gonna have you have 90 seconds, and when you redesign the station, it's really just like you that for the first station you're gonna have the 2 parallel line, right? But for the software loading, maybe you can have another option that you add one more software station, one more parallel to be 4 or something like that. But that's okay. This is like the different style. It's depending on what you're thinking about design. But a key point of this case study is that the operator didn't perform on the software. So then when we decide the layout that operate by each operator, we not account for the time because it's just let it all the calculation. Good job, actually. ขอบคุณครับ Okay, guys, see you on next week.
Thursday.
But on Thursday. Okay, enjoy your case study.